Hey guys, so we're going to talk about classes in Python and just some kind of clarifications and things from what I believe are modern patterns. And modern patterns are really, let's call it relative here, because think about where you are in Python. If you're a web dev and you're using Django, then you're going to use an ORM heavy. You're going to use different connectors for Django. You're going to use middleware that's in Django. You're going to use a different pattern than, say, a data analyst on her laptop. And she's going to use Jupyter, right? She's going to go through things with a different lens than, say, the data engineer, right? The data engineer, well, they are going to use, they're going to still use some pandas and polars, but they're going to use a little bit of classes and not a lot of OOP anywhere. Okay, and for those of you who may not be familiar with OOP, you're just starting off, object-oriented programming. So think Java, think C Sharp, think Golang. Those are kind of in the OOP paradigms, and really Golang a little less, honestly, because Golang isn't a traditional object-oriented language, kind of like a Java or C, but it still has some of the principles in kind of a non-idiomatic way. And what I mean by that is you still get encapsulation, polymorphism, composition, and that's through structs and interfaces. But that's a deeper conversation than this video is going. Basically, I want to show a couple times where in data engineering I use classes or could use classes for in Python, and why I kind of use functions everywhere else. And again, Python is really about context here. It's really relative because your web devs are going to use Python in a different way than data engineers. And that's one of the tricky things when you're using the LLMs or trying to find out what is best patterns. And I call them common patterns, right? Because whatever's best practice today is may not be best practice tomorrow. So I say common practice, common patterns, right? So I'm going to talk about what in data engineering is kind of common practice. I'm going to walk you through a little repo and where I use classes and where I don't use classes. So this may be a review for a bunch of people, but this is in the fundamentals. So I'm going to kind of go through what that looks like. First thing I'm going to start with here is my config. Let me close that out. Okay. Config's pulling from .env. So let's start .env. Basically, I am pulling weather data from a API. Okay, and this leads me into one of the places where I use, two of the places I use classes. One of them is for config. I don't use it a lot. I'm still a, Python dash .env kind of guy. I'll pull it down into a dictionary and I'll just kind of use it that way. And when it fails, I want it to fail loudly so that if there's any issues, I know immediately. Now I can do the same with classes and I can pass a class around. It gives you this strongly typed freedom so you don't have a misspelling later and all the things that come across with strongly typed. So this is one of the places where I feel like it benefits. And the other place is getting the data back from the API. You can do validation with Pydantic models, and in that validation, you can check for things just to kind of make sure that you don't have problems with your data quality coming in, right? A lot of the packages like the pandas and polars and those things, they kind of make assumptions, right? They'll check the first 1,000 rows and they'll try to guess what your data type is, which is handy, right? Unless the data is really bad, then it really breaks and you have to turn everything into strings and all the things, right? But Pydantic, you can define the checks that it does. You can do a couple things. So whenever you're bringing data in, Pydantic is good and classes are good at the boundaries. When you're bringing data in from other people, other places, data you're not sure about and you need to check, and you're not spinning up a full grid expectations or DQ or anything that has, this heavy overhead. You're not doing DBT validations. You just want to check some data coming in. Putting a Pydantic model on the boundary is the right answer. And you could even move data around on the inside using data classes. And that's fine. Like, that's a very valid pattern to use, so that you don't have functions that have 12 input parameters every single time, right? You just throw that in a class and pass that around. That's another good common pattern to use and get the strong type. So let's look at it. Let's look at a couple of these. First one is my config, and I'll show you kind of how this works. So I have Pydantic and Pydantic settings. This is the separate import that you need. I use UV, so you install it with UV add Pydantic-settings, and you get base settings instead of the base model that you normally use, which you would see in my models over here, right? My weather model, you see that this is base model, and config is actual base settings. The thing that it does here is it gives you a settings config dict, where you can pick the environment file and the encoding, and it'll automatically pull. Now, the funny thing is it uses python-.env behind the scenes. If you go to their docs and you read it, it's doing exactly what everybody else is doing. It's just wrapping them in some nice validation and strongly typed features that you can use. So if you're a fan, if you're coming from a Java or C# and you really like that strongly typed config, this is definitely a way to do it. Again, there are other ways to do it functionally, but this also gets rid of that load.env everywhere, right? I mean, you can load a dict once and pass it around, but this also gets rid of all of the os.blahs that you have all over the place, because it just automatically loads it into the class, and then you get to pass the class around. One of the gotchas here is these need to be named the same as these. Now, they're not case sensitive. You can make them case sensitive, right? But if they're not named exactly the same, then it's going to fail. If you want to name it something else, you can in this field class. You could name that something else. That's not a big deal. But just for kind of straightforward use, you can put these settings together, throw a class in here, and if you like classes and like the strongly typed, this can be your rinse and repeat for your config. So I have a config, okay? And I told you the goal was to get data from a weather API. So I'm gonna model the data. And this is what the data looks like, okay? I took a sample of the data, pulled it down, still kind of using Postman, kind of starting to go away from Postman a little bit, but I'll talk about that in a future video. But I pulled this down and understood what the shape of it was, and so I just put a little sample here of kind of what the shape looks like, and then I created my Pydantic model, and I wanted to show you what the annotation here looks like. But based what I lined up with, I have hourly units. This is my hourly units base model, matching time, temperature, precipitation, and wind speed. And then my hourly data, which is this guy, matching these things. And then the full weather response allows me to do this nested JSON, where hourly units, which is this, matches with my hourly units class. And then this hourly here matches with my hourly data class, and everything just gets deserialized kind of magically when you use this. And there's a couple ways you can use it. But I wanted to show you, these are the things that you get for free when you're using Pydantic models in this way. So this annotated is a float, and the field is greater than 0. So it has to be positive, and it's a time, so it's going to be positive. But just for purpose of demonstration, I wanted to do this. And the other thing is the robot gave me this old way, but I was reading the docs because I encourage everybody always read the documentation. This is the old way of doing it. New way is annotated, and it kind of goes into why in the docs and kind of walks through what that really looks like and what the confusions can be and what the issues can be. So make sure you're reading the docs for a few reasons, right? One is, yes, if it worked 5 years ago, it still works today. But there could have been patches for security reasons, and there could have been changes for compatibility issues, right? Issues are always coming out all the time. So make sure you're in the docs and really understanding what's going on. Just until LLMs get to the point where they're not hallucinating and not giving you a year or two old code, because it becomes an issue when you're working with something outdated that could have a bunch of flaws, a bunch of security vulnerabilities, and you're just kind of going with it. So always make sure you're doing that. That's my TED talk on docs. So I have this model, right? Those of you who come from OOP land know that most things come in classes, and these are my model classes. The way I'm going to use these is in ingest. So in ingest, well, now I have a function. Why do I have a function? Functions are stateless. Classes are stateful. So if I have a class, if I need something that holds state, and I need something that I can pass state around with, I can grab a class. There's nothing wrong with grabbing a class to hold state. That is perfectly valid Pythonic way to do it. Most of the data engineering community in 2026 has kind of landed on classes for holding state, functions everywhere else. Okay, so for this, you'll see that I am doing my structure here is my ingest. I have ingest and transform, making this like a little mini pipeline. So in my ingest, where I'm getting my data from, I'm using this async function. Have a video on async functions if you don't know, I really understand async, HTTPX, and even that Mr. Google and Docs will help you out even more. So I'm getting this asynchronously, and I'm using the with as a client, right? Why am I using with? In this context, it closes everything behind me. That's why I always use them. So it's not as much with queries for endpoints as much as it is like database connections and things. But I just get in a habit of using that so that it does the closing for me, because I know that, if you miss a con close, if you're doing a connection, then you're memory leaking and keeping things going. So I use with just as a good pattern to make sure everything closes out, mostly with database connections, but I'm using it here just for the pattern. Notice I'm pulling my base URL from my settings. Okay, and we'll see where I do settings here in a minute, because I'm passing these settings in, and this is the type hints in Python. If you're not using these, I suggest you use them. So my settings is coming in as a settings class, and I'm returning the class weather response. And you saw what the settings class is here, and you saw what the weather response is here. So in this part of it, I am taking the settings that we got, and I am using settings.nashville's latitude, settings.nashville's longitude, and the base URL. Why is my base URL not hard-coded if it's the same endpoint every time? This is an industry pattern that I use because you don't want to hard-code the URL in your code, because most places you're working with and most integrations that you have will have a dev URL and a prod URL. So having that in your environment variables is very helpful, because you're probably going to need to change it later. And you notice I put forecast in here because I may be hitting other endpoints, so I don't want to put that forecast over here in the base URL. I truly just want it to be the base URL. And this is really straightforward. It gets it back. I raise for status if I have a problem. And then I return this object with this these 2 stars from the response JSON. Now, if you don't know what the 2 stars are, okay, this is unpacking. If you don't know what those 2 stars are, and what happens is I take the response, which I lined up to be exactly the same as my weather response class, and I just unpack it into a class. And you'll see this with quargs and then a star args if you look at main methods and start pulling stuff off a command line. And this just says that these 2 stars, I'm unpacking this object here, or unpacking this dictionary into a class or into something else. So I've unpacked it. It matches this structure. So I kind of get that for free. And you'll notice how clean this is to get this data back. So I've called this function from my main method. Okay, first thing I do is I get my settings and I instantiate it because it is a class. When you instantiate it, Pydantic does all the heavy lifting for you, gets the values, pulls it in. This is kind of your one-time grab, and then you pass that settings around. Now this type ignore call -arg is because Pylance doesn't understand that settings is supposed to be pulled from the environment file. It treats it as if it's empty. So if I got rid of this, and I'll get rid of this for a second, you see it gets mad at me. It says, hey, you're missing parameters. Why don't you have parameters? I do. They're just not in my class yet because I'm pulling them from the env file. And it's a known issue. It's one of the issues on their GitHub. So people are working on it. But it is something that you have to ignore if you don't like the red squiggly. If you don't mind the red squiggly, it is what it is. Okay. So I get my settings, and then asyncio.run, that's my asynchronous call using asyncio that I installed. And get weather, I'm passing down the settings. If you want to know what that is, you just go to definition. And this was the one I showed you earlier. This is where I pass settings down. And then I grab all my settings using the nice property accessors here, my getters in this case, to grab the things. So I have those values. And I say getters, right? It's getters hypothetically because we didn't define setters or getters here. We just define them as fields, and we pull the field values down. Again, all that's happening magically behind the scenes. So I go back and I have weather. Now, I have weather as a Pydantic model. Okay, so this is validated, it's valid, it's come in. Now I want to clean it. Okay, if I'm going to clean it, I am going to use pandas here, right? And I want to clean the weather data. And it's back to a function again because I'm not passing state and I'm not managing state. I am a stateless thing. You pass something in, I return something out. It doesn't depend on the things before it or after it. Okay, so this is again as a function. And if you notice, now I could take this response and response dot, everything in response here, dot hourly. It's my hourly data because I'm just grabbing hourly data and I'm doing a model dump inside of this data frame. And now I have a data frame. I got a Polars data frame here. Now I can do all my set level aggregations. I could do all the filtering and things I want inside of the data frames. That's what the data frames are for. The Pydantic model is to give you structure and to validate the data coming in. But it's slower than a data frame for things. Now, why didn't I just start with a data frame? Again, the data frame isn't going to validate everything the way that the Pydantic model is. Okay, so that's why I'm using Pydantic models as a class. You can pull from data frames. You could do your own validation, roll your own, all the things, right? It just depends on what you're most comfortable with and what your team's using. So I clean the data, right? Do all the things here, basically just rename some columns, string the date, time, and then I return the results. Okay, we're back here. And then once I have the results, I cleaned it, I print clean, and you get this nice packaged Polars data frame return. And this is what it looks like before the Polars data frame return. Right? So this is the data. This is the nice clean version. So again, classes aren't prohibited in Python, but classes in the object-oriented sense isn't the way that we do things in Python on the data engineering side. Classes do exist if you need to pass state around, if you want to put your config in there, if you want to validate things coming in, throw it in a class. If you want to, if you look at your functions and you have 10 or 11 things coming into your function, put it in a class. Pass the class around instead of 11 different variables. But your main work here is at the function level because it's testable and easily you write PyTest on it, and we'll have a video on testing. But they're really clean. They don't hold state. And most of the time you don't need state, right? If you're just doing operations. But when you do, you grab a class. I hope this helped. I hope it clarifies. Thank you so much for tuning in. Again, please like and subscribe, and I'll see you in the next video.